Now just two special things I want to touch regarding the oxidation. This is typically for the IIDs. Oxidation of primary alcohol to aldehyde can also be carried out by MnO2, mild oxidizing agent, which does not attack saturated alcohol but does oxidize benzylic or allylic alcohol. Let's see example. Why? It's very simple, we'll discuss. This is benzylic alcohol, benzyl alcohol, it will form benzaldehyde. Or if we take an allylic one, this is an allyl alcohol. Now MnO2 is a mild oxidizing agent. It can only react with easily replace with hydrogen atoms. Now we already have seen that this benzylic hydrogen atom, this they are more acidic because of the minus I effect. Similarly, this hydrogen atom, allylic hydrogen atom, is more acidic and be more easily replaceable because the minus effect exerted by this pi bond and so, by this CH to CH group. And so these hydrogen atoms, benzylic and allylic, being easily removed, they can be oxidized by MnO2, a mild oxidizing agent, to corresponding aldehydes. But mind it won't attack saturated alcohol because there the alpha hydrogen atoms are not acidic enough. Let's take one example to make it clear. This will make it clear. If we take this example with MnO2, this is allylic. So this will be oxidized, while this is not allylic. So this won't be oxidized with MnO2. It will remain, but this will oxidize to corresponding aldehyde. Similarly, this is benzylic, while this is not benzylic. This is simply primary alcohol. So this will be oxidized, but this saturated alcohol won't be oxidized. Again, very important case. If we take this benzyl alcohol either with MnO2 or with PCC, it can form benzaldehyde. But if we take this, then only with PCC it will form corresponding aldehyde. With MnO2, no reaction because this is neither benzylic nor allylic. I want to show just one more reaction, which is a name reaction to conclude this oxidation and dehydrogenation of alcohols. Now, there is a specific reagent. This is very important for IID. Specific reagent for oxidizing. Mention remember, for oxidizing secondary alcohol to ketone. So only for secondary alcohol to ketone. The reagent is aluminium tertiary butoxide. Like this. Its formula is this CH3 Al. For simplicity, for the sake of mechanism, as I will show the mechanism in details, we can show like this. Three such groups is attached to aluminium. Its structure, if we consider, and this will make it clear. This is its structure. This is a specific reagent for using of oxidizing secondary alcohol to ketone only, and this is a typical reaction, name reaction called open-OR oxidation or open-OR reaction, in which a secondary alcohol is refluxed with this reagent, aluminum tertiary dioxide, and then treated with either acetone or cyclohexanone. Now let's see the mechanism. This mechanism is totally different from the earlier oxidation mechanism we have seen. Secondary alcohol, mind it. For the sake of mechanism, I am showing aluminum tertiary butoxide in this form. As I've said, just a moment. Secondary alcohol is treated with aluminum tertiary butoxide followed by acetone or cyclohexanone. The first step, this alcohol, secondary alcohol is treated with tertiary butoxide, aluminum tertiary butoxide, is nothing but neutralization reaction, which is a reaction with strong acid and strong base forming weak base and weak acid. See, if this is secondary alcohol and this is tertiary alcohol. We all know the acidity of alcohols, as we have done in alcohol chapter, decreases as primary greater than secondary greater than tertiary because of the stability of the corresponding conjugate base. I am not going to discuss this at this stage, but we know that this is more acidic than this. And again, this is more basic because the more plus I effect, the more electron density on oxygen atom or O minus and so than this. So the first step is the simple neutralization reaction with strong acid and strong base forming weak acid and weak base. In the next step, when acetone is added, there is a typical reaction occurring, which is an intermolecular hydride shift, solvent independent, intermolecular. This bond between O and L is coming here, creating a double bond. 1, 2, 3, 4, tetravalent satisfied. This H is H minus will migrate from this to acetone or cyclohexanone. I am saying cyclohexanone and cyclohexanone. This is like this. So in the process, this is called oxidized to CH3, CH2, CO, CH3, and this is reduced to CH3, this is reduced to this acetone is forming aluminium isopropoxide, which is actually a starting material for this. This is a reversible reaction. For the reverse reaction, which is another important reaction of the aldehyde ketone reaction chapter, which is MPV reduction, we call it. Now, how to make this is a reversible reaction, how to make this forward reaction possible, how to make this open order reaction highly feasible. First of all, here the hydride shift, kinetically speaking, hydride shift is occurring for more crowded. See, there is more crowding here than this. That's why this or this is taken, less crowded among ketones. Hydride shift is occurring from more crowded to less crowded. Moreover, this is the most important thing, experimental part. Moreover, acetone or cyclohexanone is taken in excess. So according to that Lecher's principle and so on, so physical concept, the equilibrium shifts in the forward direction and the reaction is almost complete. Okay? Now what is its application? It's a very important application. This specific reagent, aluminum tertiary butoxide, is used for oxidizing unsaturated secondary alcohol because it does not affect the double bond. Never affects the double bond. One very good application I am going to show here, which is very important for the iodine. Ke often comes suppose we have to carry out this conversion. Secondary alcohol to ketone. We know not a lot of oxidizing agents, we can do it. But here, using any other oxidizing agent other than aluminum tertiary butoxide, there is a risk of cleavage at this benzylic carbon, forming benzoic acid and side product. This one we form. Using any other oxidizing agent discussed earlier, there will be cleavage across this, be it KMnO4, be it dichromate, be it CrO3, there will be cleavage across this, giving benzoic acid plus corresponding. For this oxidation to take place, for this reaction to take place, without converting this or breaking this carbon-carbon bond, we have to use opener oxidation. That means we have to use aluminum tertiary butoxide. This, in a nutshell, completes our discussion of one of the methods of the preparation of aldehydes and ketone general methods, which is oxidation and dehydrogenation of alcohols. Thank you.